Hi everyone, and welcome back to Maths and Physics from Mr. Simons. Right, we make Maths and Physics simple and we get you exam ready. Right, so in today's lesson we're looking at Euclidean geometry and specifically Theorem 1b. So in the previous lesson we did Theorem 1a. This lesson we're looking at Theorem 1b, so one of the two normally gets tested in grade 11 and sometimes in grade 12 as a proof, as one of your proofs that you have to answer in exam. Theorem 1b goes as follows. The line drawn from center of a circle, perpendicular to a chord, bisects the chord. So they say perpendicular from center to chord. Previous one was midpoint chord. So line from center, perpendicular to chord. So given to us in the exam, when we want you to prove, would be a circle with center O, and OD perpendicular to AD. So there where OD meets AB, T1 and T2 are 90 degrees. Now we have to prove that this line AD is equal to TB. So we're doing the reverse of what we did in the previous theorem. So in Theorem 1a, they gave me the two sides, and I had to prove that T1 and T2 are 90. Now D1 and D2 was given as 90, and I have to prove that AD equal TB. Right, so, but as I said in the previous theorem, we always start the proof with construction. So let's see. My formal proof for my first mark, construction, draw OA and OB. So we're going to draw from O to A, from O to B. Right, here's my circle. So from O to the circumference of the circle, and from O to B, there the circumference of the circle, we're dealing with two radii. Right, again, we're going to look at triangle AOD and triangle BOD, and we're going to try to prove them as congruent. Right, so first and foremost, OA equal OB, and those two lines in blue are equal, and the reason is it's a radii, it's a radius and a radius, they must be the same length. Then T1 equal T2, it's given. Right, they both equal to 90 degrees. Then we have this line in the middle that belongs to both triangles. OD equals OD, common side, right? So I could say OD is common, or I can say OD equal OD, common side. Right, so there you can see I have a side, 90 degrees, and I have a side. So if I look across the 90 degrees, I always have the hypotenuse. No? So that's a hypotenuse, right? This would be, my reason then would be AOB, that's hypotenuse. This here, a right angle, and that their side. So therefore, triangle AOD is congruent to triangle OBD. And we say right angle, which is 90 degrees, hypotenuse side. Right? Now, because they are congruent, they are exactly the same in every sense of the word. So I could technically take this, and if I fold it over, it will perfectly fit on the other triangle. So therefore, I can conclude that AD equals DB, and now my reason is congruent triangles. Right? And that proof is done. In the next video, next lesson, before we go to proofs, I'm going to do some basic Theorem 1 problems using Theorem of Pythagoras, and we're going to solve some problems related to Theorem 1. That's just to make sure you understand how we use this theorem now. So yeah, for this theorem here, if I wanted to say AD equal DB in formal sense, I would say my reason is a line from center perpendicular to chord. So that line from the center there is perpendicular to chord, therefore those two are equal. Right, but we will look at all of that in the problems. Done with that problems, then we're going to look at Theorem 2. Right, continue practicing. Wish you nothing but the best. God bless. Bye.